This is Professor Maragadam from Department of Civil Engineering of Faculty of Engineering of Vinashalingam University for Women, Coimbatore. In this chapter, we'll see about what is a beam, what are the different types of beams, how the beams are supported, and based on the supports, how the beams are named. All those things we'll see in detail, one after the other. First of all, let us see what is a beam. A beam is a structural member subjected to external loads which are acting at right angle to the longitudinal axis. You can see the longitudinal axis and the loads W1, W2 and W3 which are acting on this beam. The beam of length L is given here. So a structural member subjected to external loads. These are the external loads which are acting at right angle to the longitudinal axis. This is the longitudinal axis of the beam, and the loads are acting at 90 degrees to this longitudinal axis. This is a beam. If the loads are acting this way, suppose if this is the longitudinal axis and the loads are not at 90 degrees, what is the name of that structural member? That we can see in the second figure. If the external forces acts along the longitudinal axis, say this is a member and this line is a longitudinal axis, and the load acting on this member is in this way, this is in line with the longitudinal axis, and the load and longitudinal axis are on the same line. In the beam, it is acting at 90 degrees to the longitudinal axis. Here it is acting along the line. This member is known as a column. About the column, we'll be studying in detail in the later chapters. Now this is a beam. How this beam and the column can be clubbed together and say at a particular joint, we say that it is a beam column. And this is a member where this member is subjected to both loads, the axial load and the transverse load. The axial load is along the longitudinal axis of the beam. The forces are acting here. The intensity of the force may be something. And perpendicular to the longitudinal axis, as what we have seen in the beam in the first figure, is also here. The combination of both the axial forces and the transverse forces acting simultaneously on a structural member is known as a beam column. Beam where the load is acting at 90 degrees to the longitudinal axis, where the load and the longitudinal axis are in line, it is known as a column. When the structural member is subjected to both the loads or both the forces acting in the axial direction as well as in the transverse direction, it's known as a beam column. Let's see about the types of beams. What are all the different types of the beams? The first one is a simple beam. Simple beam is nothing but the beam supported at two ends. At one end it is hinge, the other end is a roller. Both the ends are supported, and totally at both supports the number of unknowns should not exceed the value 3. There should be only 3 unknowns in a beam. If the unknowns are only 3, the beam is known as a statically determinate beam. What are all the statically determinate beams? One is a simple beam where one end is a hinge, the other end is a roller. The other is an overhanging beam. Overhanging beam is simply supported beam extended at one end beyond the right support or beyond the left support, anywhere. It's overhanging beam. Overhanging on one end or overhanging on the other end. And the third one is a cantilever beam. Cantilever beam, one end is fixed and the other end is free. In that case also, only on the fixed end there will be 3 unknowns. The reaction, vertical reaction, horizontal reaction and the moment. All the 3 are the unknowns. So the first simple beam, overhanging beam and the cantilever beam. All the three beams are known as a statically determinate beams. In all the three beams, only three unknowns will be there. All these three unknowns can be solved using the equilibrium equations, that is algebraic sum of all the vertical forces is equal to 0, horizontal forces is equal to 0, and the summation of the moment, taking moment about any one support point and including all the loads and the reactions at the fixed end, free end, and also the supporting points are equated to 0, we can find out the unknowns. When you are able to find out the unknowns of a beam using the three equations, sigma v is equal to 0, sigma h is equal to 0, and sigma m is equal to 0. If you are able to get the unknown values using these three equations, we say that it is a statically determinate beam. And next three are the fixed beam. Fixed beam is one end is fixed like a cantilever, the other end, free end of the cantilever, is also fixed. If the both the ends are fixed, there will be six unknowns. At one support where it is fixed, we have three unknowns: vertical reaction, horizontal reaction, and the moment. Similarly, at the other support also we have the unknowns as vertical reaction and horizontal, and also the moment. So there will be six unknowns in the fixed beam. To solve for the six unknowns, the equilibrium equation of sigma v is equal to 0, sigma h is equal to 0, and sigma m is not m is equal to 0 is not sufficient to get the values of the unknowns. And next is the continuous beam. In the continuous beam also, the beam is supported on a hinge and two or more roller supports. So the same beam, there will not be only two supports, there will be more than two supports. One support may be hinge, the other support may be roller, and the other support, third support, may be hinge or roller. So if the beam has got more than two supports, it is known as a continuous beam. And next is a propped cantilever beam. Already we have seen a cantilever beam which is a statically determinate one where one end is fixed, the other end is free. Now this is a propped cantilever beam where one end is fixed, like where horizontal, vertical moment, horizontal force, vertical force, and the moment are the three unknowns, and the propped is the free end is supported. Free end is simply supported at the free end. So there will be another unknown. So the number of unknowns in this propped cantilever will be more than 3, hence it comes under the category of statically indeterminate beams. Now you can see the simply supported beam, where I have told you already there should be a maximum of 3 unknowns, where the simply supported beam is supported simply at both the ends. One end may be hinge, the other end may be roller. You can see the hinge. At the hinge there will be 2 unknowns. One is in the vertical direction and other is in the horizontal direction. In the roller, this is the rolling moment. Perpendicular to that is arrested. So this is an unknown. So the unknown here is 1, 2 and 3. There are only maximum of 3 unknowns in this. So this comes under the statically determinate structure where we can solve for the unknowns using the equilibrium equation sigma v is equal to 0. That is the algebraic sum of all the vertical forces equal to 0, and sigma h is equal to 0 if there is any horizontal forces. We can take the algebraic sum of all the horizontal forces equal to 0, and sigma m is equal to 0. Taking moment about any one support and equating that to 0, we can solve for the unknowns, all the 3. So this is a statically determinate, simply supported beam. Only 2 supports, one may be hinge, the other may be roller. Next we have seen the overhanging beams. Overhanging beams is the beam is supported at its end with a hinge at one end and roller at the other end, and it has got some projection after the support, that is known as overhang. This is hanging, this portion is hanging. You cannot call this portion as a cantilever because this is not the fixed one. This is a support, hinge support. From the hinge support there is a beam extended, but there is no support at the free end of this. So we say this portion is an overhang.
So the beam which has got two supports, one is a hinge, the other is a roller. The roller, there will be only one unknown like this. For the hinge, there will be two unknowns. There is no support here. So the total number of unknowns here is 1 plus 2 here. So 3. The number of unknowns is equal to 3. We can say it is a statically determinate beams. So overhanging beam on one side or overhanging on the other side, both are called as a statically determinate beam. Suppose in this, if you have a beam extended on this side, if there is no support, only two supports are here. One is a hinge, the other is a roller. So the number of unknowns here is 1 plus 2 is equal to 3. In this case also overhanging on both sides is also called as a determinate. It comes under the determinate beams category. And the third one in the determinate beam is the cantilever beam. The number of unknowns is equal to 3. What we have said earlier. If you take a fixed beam, this end is fixed. At the fixed end, reaction in the vertical side, horizontal reaction, and the moment. The three unknowns are here. The other end is free. So the three unknowns can be solved using the equilibrium equation sigma V is equal to 0, sigma H is equal to 0, sigma M is equal to 0. When you are able to solve these three equations, three unknowns using the three equilibrium equations, we say it is a statically determinate beam. So the simple beam, simply supported beam, overhanging on one side or overhanging on other side, or a cantilever beam. All these three comes under the category of the statically determinate beams. These statically determinate beams, for which we can draw the shear force and bending moment diagram and find out what will happen when the if it is subjected to the load, either a vertical load or a moment or whatever may be the type of load, how, what is the shearing force or shear force at each and every section along the span of the beam, and how it bends, what will be the bending moment, all those things we will be seeing in a different chapter. And about the statically determinate beams, this is a indeterminate beam where the number of unknowns is more than 3. Here there will be 3 unknowns. With this fixed support there will be 3 unknowns. So there will be 6 unknowns in this. So we cannot